Assalamu alaikum sabayo shabab. I prefer to record a YouTube clip, a short one, related with the experiment 4 about the free falling object. I want to mention very important thing about the simulation, and I want everybody to get it because it's a little bit tricky. And I want you to be on time while doing these things, so we will not be running out of time the last day or the due date. Now, if you can see, this is a very short report. If you see, like, it is just the intro page and these equations, and if you see these equations, these are our equations of motion. You know, there is nothing new about these three equations of motion. We all know them, and there is something interesting actually in these equations of motion, that they are referring to delta y as h, which makes sense because they are basically talking about the height. So instead of just writing delta y, we mention it as h, and he made it easier for us to say g in, you know, like instead of a and then replacing it by g, because literally this is a free fall experiment. So this is v final is equal v initial plus gt, and this is just because we need to do calculations for the t. So this is just coming from the rearrangement of this equation. So this is not a new equation. This is our equation, this is our equation, and this is our equation. And if you see that delta y is referred to as h, and of course a is referred to as g. The nice thing in the free fall problems that we don't have different a. It's always g. While in the one dimension we used to have different acceleration, sometimes constant speed, so acceleration is 0. So in one dimension, in the horizontal axis, it used to be a bit more complicated, if you will say, but here we only have one kind of acceleration, which is the gravitational acceleration. All right, that's all just the physics part of it. Now here it comes to the simulation. Now if you have a MacBook, you remember when I told you you have to download the JAR, which comes from Java, and I think you guys already did that, and you upload it or whatever, download it on your laptop. Anyway, this is also requiring something like that. Let me just go from the draw, just a minute. And actually I have another YouTube which literally explain the issue you will face once you will do it on just a second. Let me just get back to my normal hand. Okay, I have, you know, once you do it like that, okay, there is this link here which says download so and so JAR, and once you click on that, you will see here the downloading. You need to do that today. I'm recording at 3 a.m. I understand, but you need to do it today, by of course the end of the day, so that we will make sure that everybody have it working before you go to the weekend. Okay, let me see. Okay, oh, you see, even though I downloaded, it doesn't show anything. I have to go to the computer setting and go to security and privacy and click the lock and use just the password of your computer to say unlock, and then you just say open anywhere and you say open, and here, okay, you see the program open. But if you don't do this unlock in the privacy thing, and open anyway, these two steps will not allow you to open your software. And then you click on play, and you see the free fall here. It's an object which is falling under the gravitational, and here the changing of position. It was on height of 20, it came down maybe to, you know, like 18, it came down to 15, and then to 0. And this is the graph of the position, this is the graph of the velocity, and the interesting thing that this is the graph of the acceleration. The position is decreasing, the velocity is constant. Is it constant? No, it's not constant. Actually, the velocity is also changing, and it is actually increasing. If you see, ignore the negative for a while. The velocity started from, for example, 0 because it's a free fall, and it becomes 5, 10, 15, and just before it hits the ground, it becomes 20 downward. And this is what we mentioned in the classroom, that the velocity starts from 0 at the top, and it keeps increasing till it reaches the maximum velocity before it hits the ground. But the very interesting thing, that what is the value of the acceleration? Okay, they're approximating it to 10. Actually, it's a constant 9.8, which is here 10. I told you that's not a big deal. So, and it's constant. So the only constant thing here is the acceleration. Position will never be constant. Velocity will never be constant. Only the acceleration is constant, which is not any constant. It's the G, 9.8, which is approximately 10. You can restart. Okay, you can pause. You see? So anyway, this is all what I want to show you here. Let me just close this window. All right, and then where is the report here? So that is very important part. You have to be done with it today. That's why I am actually sending the YouTube before even we start our day or anything, so that the students will have it, and anytime you can see it. I will upload this experiment now on the Blackboard, and you will have it from the beginning of your day, and you should be able to at least set the simulation. That I'm not asking you today to do the report, but at least this part of the report should be done today. Now, these are steps that you will follow, and they are just one page, see? But you need to go through them carefully, that's it, you see? The main thing in this report is the simulation. Now, I will see you, of course, today, inshallah, from 12 to 1. And I will see you, of course, on Sunday for 3 hours. The first one is 10 to 11, and then 1 to 3. I would really, guys, I would appreciate it if you will do your homework, your lab report. You can start with it, no problem. Tomorrow, at least the simulation, you can work on it in the weekend. And on Sunday, most probably in the second part of the day, like from 1 to 3, I will set like 20 minutes or 15 minutes for anything the students would like to ask about, and that will be all that I am gonna answer about the lab report. On Sunday, from 1 to 3, I will devote 10 to 15 minutes, whatever time is required, like short time required, to answer any of your concern. So you better be ready by Sunday afternoon for asking anything. I will set the due date to be Monday, end of the day on Monday, but I will not be available to answer your questions few hours before the submission due date. So I hope that I am making myself clear. You work on your report, make sure the simulation is ready today. Set, whatever, work in groups, work whatever, but submit it individually. But I will be available to answer your questions about the report on Sunday afternoon during our 2-hour session. I will devote some time to answer your questions. Thank you guys, and I hope that this lab will be smooth for you. Take care.